Today's video, I would like to introduce you a very nice problem of Croatian Mathematical Olympiad edition 2006, question number 4. Okay, here is the following question. Find all natural solutions x and y as a natural numbers. We have the following equation: 3 to the x equals 2 to the x is multiplied by y plus number 1. Okay, in fact, this is very nice problem, but it's more tricky. Okay, so the hint that I'm trying to give to this problem, so we are going to use very strong and useful lemma, is called lifting the exponent. If p is a prime, x and y as an integers, such that if you have a prime p, divide the difference x minus the difference of x and y, or prime divide the sum of these integers. And also GCD of this prime and y equals to the GCD of p and y equals number 1. If p is odd, we have this lifting exponent vp of x to the n minus y to the n equals vp of the difference of these integers plus this lifting exponent of the exponent n as a natural number. Okay, if p is even, we have this following statement. We have vp of x to the n minus y to the n equals the difference of these integers plus the exponent of the sum of these integers minus number 1. Okay, m to be the exponent of in prime factorization. Vp m of m equals k, so the p to the k divide m, but p to the k minus 1 not divide m. Okay, so when we get to the solution, I'm going to show you how this one interfere with this problem. Okay, go ahead, pause this video if you would like to give it a try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution now. The first thing, I'm going to try the obvious case. Let's try x equal to 0 as a first solution. By plugging number 0 into x here, I will have 3 to the 0 equals 2 to the 0 is multiplied by y plus number 1. So this one is giving us 3 to the 0, which is 1. 2 to the 0 is giving us number 1 plus 1. So y equal to 0. I will have the first solution x equal to 0 and y equal to 0. Okay, so I'm going to break this one into two cases. We will have x as an odd number, and also we will have x as an even number. So the case number 1, x odd. So I have this equation. I'm going to move over number 1 to the left hand side of this equation. As we know, I'm going to reduce this one to the marginal 4 by using the congruence definition. So I have 3 to the x minus 1 is a congruent to minus 1 to the x minus 1 is a congruent. As we know, x is a odd. This one is turned into minus 1. Minus 1 minus 1 is giving us minus 2. Is a congruent to mod 4. Okay, this term also is a congruent to minus 2 mod 4 because we have equality. Okay, so is a congruent to x is multiplied by y mod 4. Okay, by taking this one to the left hand side and make number 2 as a common factor at the same time, we'll have minus 2 is multiplied by 2 to the x minus 1 is multiplied by y plus number 1 is a congruent to 0 mod 4. So now this expression is telling us for divide this product. Okay, but the problem for not divide number 2 because 4 is a bigger than 2. Okay, but for not divide number 2 and also for not divide this term to the x minus 1 is multiplied by y plus 1 because this one is a odd. Okay, because 2 to the x minus 1 is multiplied by y is a even plus number 1 becomes odd. Never ever find even divide odd, but you can find odd divide even. Okay, let's take area 1 over 24 as an example. 24 is a even, not divide area 1 as a odd because area 1 is 3 is multiplied by 27 is divided by 3 is multiplied by 8. This one is giving us 27 over 8. So 27 over 8 is not an integer. Okay, so that's mean even, not divide odd. Let's take another example. If you have a fraction 6 over 3, 6 over 3, that's mean 3 divide 6, that's mean odd divide even. This one is given as number 2 is a whole number. That's mean odd can divide even, but even cannot divide odd. That's what happened here. Okay, to maintain order and make this divisibility work correctly here, so we are going to give the exponent x minus 1 0. Okay, that's the only way to get this divisibility correct. Okay, because if you give the exponent 0, that means 2 to 0 is 1, it will be possible for divide y plus 1. Okay, so that's what I'm gonna do now. So this one, to have this divisibility verified, so that implies x minus 1 equal to 0. This implies x equal to 1. I'm going to take this found fact and insert it into the original equation to find y. So I have 3 to the x, which is 3 to the 1, equals 2 to the 1 is multiplied by y plus number 1. By taking number 1 to the left hand side of this equation and divide both sides by 2, I get y equal 1. Okay, solution, x equal to 1 and y equal to 1. Now let's move on to the next case to discuss when we have x as an even number. Okay, when we have x as an even number, we have this equation 3 to the x equals to this one. So now I'm going to take number 1 to the left hand side of this equation. So we'll have 3 to the x minus number 1 equals 2 to the x is multiplied by y. Okay, as we know, x is an even. I will have a factorable polynomial here, so this one I can factor it out on the form of 2 difference of the squares. So I will have 2 terms on this form. 3 to the 2n minus 1 equals 3 to the n minus 1 factor 3 to the n plus number 1. Okay, equals to this term, for example 2 to the n, because x is an even. You might say you have a power of 2 here because you have this number is an even, this one is an even. Okay, but the problem on the right hand side of this equation, we don't know y is a known variable. So y, if we take an odd, for example, it will make you a problem. So in order to have this power of factorization prime work perfectly, so you have to have y equal to 2 to make sure you have a power of 2, because we don't know the power of 2 in y. Okay, so now this is not guaranteed to apply the factorization prime power. Okay, so now you may get solution, but you get the partial solutions. You are not able to get the full solutions. You may miss another solution if you apply this formula. Okay, so this formula won't work. Okay, so that's why we are going to apply this formula. This is very strong and useful lemma. Okay, this one can solve our problem as an exponent. By applying this lemma, before we start applying this rule, we have to check is this one is verifying the initial conditions or not. So because we have p must divide the difference of these two numbers. So these two numbers, like I have 3 to the x minus 1 to the x. So I have 3 as a x and y as number 1. Okay, let's set equal to 2 as a prime. So p2 divides the difference of these numbers, 3 minus 1. 2 divide 3 minus 1, the difference of these two numbers. And also GCD of this prime 2 and number 3 equals GCD of prime 2 and number 1 equals 1. Okay, so all these three conditions are verified our setup. That means we are allowed to apply this lemma. Okay, so now by applying this lemma, I'm going to apply this lemma on both sides. I will have v of 2 as a prime equals 3 to the x minus 1 to the x equals v of 2 to this number 2 to the x is multiplied by y. Now I'm going to calculate this one on the left side. Left-hand exponent v of 2 v2 of 3 to the x minus 1 to the x. I'm going to apply this formula because we have prime is an even as we have here. This means v of 2. I'm taking the difference of these two numbers, 3 minus 1 plus v2, the sum of these numbers, plus v of 2 of the exponent. Exponent as a natural number. You have to have natural number here, x. That's what we have in our conditions. So minus number 1 at the end. Okay, at the same time equal to this one, v of 2 to the x is multiplied by y. So this one, I'm taking just the exponent of this one. So 3 minus 1 is 2. The exponent is 1. Okay? Plus v of 2. 3 plus 1 is 4 to the 2. As we have in our definition, Vp of m equals k as an exponent. So now, and also I'm taking this exponent also, because this exponent 2 must be written on the form of the prime, okay? Plus v2 of x. I'm going to leave this one as is, minus number 1. I'm going to apply the definition of this left-hand exponent. So this one, I'm going to put this one, the product of two numbers inside of this one is giving us the sum of this one. We'll have v of 2 to the x plus v of 2 of y. Okay? v of 2 of 3 to the x minus 1 to the x. This one is given as number 1 because we are taking only exponents. Plus number 2 plus v of 2x minus number 1. This one also, I pick up just this exponent, x plus v of 2 of y. But we don't know the value of this one. We don't know this one. But this one, what we know about this one, we know only v2 of y is a positive number. Is superior equal to 0. Is superior equal to 0. That's what we know about it. Okay? This one is giving me, so this number 1 will be cancelled out with minus 1. I will have 2 plus v of 2 of x equals to x plus v of 2 of y. Now I'm going to transfer this equality into inequality. This one is superior equal to x because we know v of 2 of y is a positive. Okay, it's superior equal to 0. I'm going to move over this number 2 on the right hand side of this inequality. I will have v of 2 of x is a superior equal to x minus 2. Okay, this one implies x is superior equal to 2 to the x minus 2. Okay, this statement is true. Okay, by taking x out of this one, now we have extracted this inequality. But the problem, if you have x equal to 5, if you replace 5 into this inequality, we'll have 5 is superior equal to, I'm going to replace 5 with this exponent. I will have 5 minus 2 is equal to 3. To the 3 is equal to 8. That means 5 is superior equal to the 8, which is impossible. So that's mean, so this inequality hold this condition as long as we have x is inferior or equal to 4. So this inequality is valid for only when we have x is inferior or equal to 4. If you replace x with 4, it will have 4 here. I will have 2. 4 minus 2 is giving us 2. 2 to the 2 is 4. So that means 4 is superior or equal to 4. That's correct. Okay? Because if x is strictly superior than 5, this inequality is changing the direction. You will have this one. Okay? Now I'm going to find the solutions of x and y. Now we have x is inferior or equal to 4. That means x is taking this set 2 and 4 because x is an even. If x equal to 2, I'm going to replace x with number 2 into the original equation. I will have 3 to the 2, which is 9, equals 2 to the 2 is multiplied by y plus number 1. I will take number 1 to the left hand side. I will have 8 equals 4 is multiplied by y. By dividing both sides by number 2, we will have y equals 2. Now we'll have another solution, x equals 2 and y equals 2. I'm going to find another solution, another possibility, because we have x, when I have x equal to 4, I'm going to replace x with number 4. I will have 3 to the 4 equals 2 to the 4 is multiplied by y plus number 1. Okay, 3 to the 4 is giving us area 1. By taking number 1 to the left hand side, you have minus 1, which is area. Area equal 2 to the 4 is 16 is multiplied by y. By dividing both sides by 16, I will get y equal 18 over 16 equals to 5. Now we have find another solution, x equal to 4 and y equals to 5. Okay, now we will have x is an even I have two solutions. When we have x is an odd, I found only one solution, x equal to 1 and y equal to 1, and we have obvious case, we have 0 0. So I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.